using hosts to avoid duplication. Another common use case for hosts is to encapsulate setup and tear down operations. For example, interacting with a database requires some setup to acquire and open a connection, and some cleaning up after the interaction to close the connection and return it to the underlying connection pool. In code, it looks like the following: setup, acquire, and open a connection. Tear down, close and release the connection. The setup and tear down are always identical, regardless of whether you're reading or writing to the database, or performing one or many actions. The preceding code is usually written with a using block like this. This is both shorter and better. But it's still essentially the same. Consider the following example of a simple DB logger class with a couple of methods that interact with the database. Log inserts a given log message, and get logs retrieves all logs since a given date. Exposes executable and query as extension methods to the connection. Assume this is set in the constructor setup. Notice that the two methods have some duplication, namely the setup and tear down logic. Can we get rid of the duplication? The specifics of the interaction with the database are irrelevant for this discussion. But if you are interested, the code uses the Dapper library documented on GitHub. github.com/exchange dapper.net, which is a thin layer on top of ado.net, allowing you to interact with the database through a very simple API. Query queries the database and returns the deserialized log messages. Execute runs the stored procedure and returns the number of affected rows which were disregarded. Both methods are defined as extension methods on the connection. More importantly, notice how in both cases the database interaction depends on the acquired connection and returns some data. This will allow you to represent the database interaction as a function from IDB connection to something. Asynchronous I/O operations. In real world scenario, I'd recommend you always perform your operations asynchronously. So in this example, get logs should really call query async and return a task enumerable log message. But asynchrony adds a level of complexity that's not helpful while we are trying to learn the already challenging ideas of FP. For pedagogical purposes, I'll wait until chapter 13 to discuss asynchrony. As you can see, Dapper exposes a pleasant API and it will even open the connection if necessary. But you're still required to create the connection and you should dispose it as soon as possible. Once you're done with it, as a result, the mint of your database calls ends up sandwiched meat of your database calls ends up sandwiched between identical pieces of code that perform setup and teardown. Let's look at how you can avoid this duplication by extracting the setup and teardown logic into a HOF. Encapsulating setup and teardown into a HOF. You are looking to write a function that performs setup and teardown, and that's parameterized on what to do in between. This is a perfect scenario for a HOF because you can represent the logic in between with a function. Graphically, it looks like figure 1.8. A HOF that wraps a given function between setup and teardown logic. Because connection setup and teardown are much more general than dblogger, they can be extracted to a new connection helper class, encapsulating setup and teardown of the database connection into a HOF. What happens in between is now parameterized. The connect function performs the setup and teardown, and it's parameterized by what it should do in between. The signature of the body is interesting. It takes a IDB connection, though, which it will interact with the database, and returns a generic object R. In the use cases we've seen, R will be enumerable log message. In the case of the query, and int in the case of the insert. You can now use connect function in dblogger as follows. You got rid of the duplication in dblogger, and dblogger no longer needs to know the details about creating, opening, or disposing of the connection. Turning the using statement into a HOF. The previous result is satisfactory, but to take the idea of HOF a bit further, let's be a bit more radical. Isn't the using statement itself an example of setup teardown? After a using block always does the following. After all, using block always does the following. Setup acquires an ID disposable resource by evaluating a given declaration of expression. Body executes what's inside the block. Teardown exits the block, causing dispose to be called on the object acquired in the setup. So yes, it is, at least sort of. The setup isn't always the same, so it too needs to be parameterized. We can then write a more generic setup teardown hof that performs the using ceremony. This is the kind of widely reusable function that belongs in a library. Throughout the book, I'll show you many such reusable constructs that have gone into my Layamba.functional library, enabling a better experience when coding functionally. A hof that can be used instead of using statement. The preceding listing defines a class called f that will contain a core function of our functional library. The idea is that the functions should be made available without qualification with using static, as shown in the next code example. This using function takes two arguments. The first is disposable resource, and the second is the function to be executed before the resource is disposed. With this in place, you can rewrite the connect function more concisely. The using static on the first line enables you to invoke the using function as sort of global replacement for using statement. Notice that unlike the using statement, calling the using function is an expression. This has a couple of benefits. It allows you to use the more compact expression bodied method syntax. An expression has a value, so the using function can be composed with other functions. We'll dig deeper into the idea of composition and statements versus expression in section 5.5.1. Trade-offs of hofs. Let's look at what you've achieved by comparing the initial and the refactored versions of one of the methods in dblogger. This is a good illustration of the benefits you can get from using hofs that take a function as an argument. Conciseness. The new version is obviously more concise. Generally speaking, the more intricate the setup teardown and the more widely it's required, the more benefit you get by abstracting it into a hof. Avoid duplication. The whole setup teardown logic is now performed in a single place. Separation of concerns. You've managed to isolate connection management into the connection helper class, so dblogger need only concern itself with logging specific logic. Let's look at how the call stack has changed. Whereas in the original implementation the call to execute happened on the stack frame of log, in the new implementation therefore stack frames apart. Hoves call back into the calling function. When log executes, the code calls connect, passing it the callback function to invoke when the connection is ready. Connect in turn packages the callback into a new call back and passes it to using. So hoves also have some drawbacks. You've increased stack use. There is a performance impact, but it's negligible. Debugging the application will be a bit more complex because of the callbacks. Overall, the improvements made to dblogger make it a worthy trade-off. You probably agree by now that hoves are very powerful tools, although overuse can make it difficult to understand what the code is doing. Use hoves when appropriate, but be mindful of readability. Use short lambdas, clear naming and meaningful indentation. Benefits of functional programming. The previous section demonstrated how you can use hoves to avoid duplication and achieve better separation of concerns. Indeed, one of the advantages of FP is its conciseness. You can achieve the same result with fewer lines of code. Multiply that by the tens of thousands of lines of code in a typical application, and conciseness also has a positive effect on the maintainability of the application. There are many more benefits to be reaped by applying the functional techniques you'll learn in this book, and they roughly fall into three categories. Cleaner code. Apart from the previously mentioned conciseness, FP leads to more expressive, more readable, and more easily testable code. Clean code is not just a developer's intellectual pleasure, but it also leads to huge economic benefits for the business through reduced maintenance cost. Better support for concurrency. Several factors, from multi-core CPUs to distributed systems, bring a high degree of concurrency to your applications. Concurrency is traditionally associated with difficult problems such as deadlocks, lost updates, and more. FP offers techniques that prevent these problems from occurring. You'll see an introductory example in chapter 2 and more advanced examples towards the end of the book. Multi-paradigm approach. They say that if the only tool you have is a hammer, every problem will look like a nail. Conversely, the more angles from which you can view a given problem, the more likely it is that you'll find an optimal solution. If you are already proficient in OOP, learning a different paradigm such as FP will eventually give you a richer perspective. When faced with a problem, you'll be able to consider several approaches and pick the most effective. Exercises. I recommend you take the time to do the exercises and come up with a few of your own along the way. The code samples repository on GitHub, github.com slash layumba slash functional C# code includes placeholders so that you can write, compile and run your code with minimal setup effort. It also includes solutions that you can check your results against. First, browse the methods of system.link.enumerable, which are hosts. Which do you think simply iterated application of given function? Second, write a function that negates a given predicate whenever the given predicate evaluates to true. The resulting function evaluates to false and vice versa. 3. Write a method that uses quicksort to sort list int. Return a new list rather than sorting it in place. 4. Generalize the previous implementation to take a list T and additionally a comparison T delegate. 5. In this chapter you've seen using function that takes an idisposable and function of type funct_tdisp. Write an overload of using that takes a func_idisposable as the first parameter instead of idisposable. This can be used to avoid warnings raised by some code analysis tools about initiating an idisposable and non-disposable method. Summary. If-pay is a powerful paradigm that can help you make your code more concise, maintainable, expressive, robust, testable, and concurrency-free. If-pay differs from OOP by focusing on functions rather than objects, and on data transformations rather than state notation. FP can be seen as a collection of techniques that are based on two fundamental tenets: methods, delegates, and lambdas. FP leverages higher order functions, functions that take other functions as inputs or output. Hence the necessity for the language to have functions as first-class values.